a summary of curve sketching. We will combine all of your graphing techniques that you've learned from algebra and from calculus here into this discussion. And so you want to be able to recall how to find the x and y intercepts, domain, range if necessary, vertical isotopes, horizontal isotopes, relative maximum, relative minimums, concavity, points of inflection. Here's some guidelines. You want to be able to find and test the signs of partitioning the intervals for the y values, for y prime, and then also for y double prime. We look at the sign values by partitioning the number line to see where the graph is either above or below the x-axis. In terms of y prime, looking at those sign shifts, you're concerned with increasing intervals, decreasing intervals, and thus you can also get the relative extrema. When you check y double prime or f double prime, you're checking for concavity. If you have positive, that means that the curve or the graph is set to concave upward. If you have negative sign shift for y double prime, that means that the concavity is downward. If the concavity changes, then you recall that you have a point of inflection. So with that in mind, and here's the thing, but some of these functions, if you look at them and remember like where they come from, you might not have to go through all of that. It just depends on the particular function. Take number 5, for example. Number 5 is something straight out of Compton, algebra. If you recall that based on this format, this -3 tells us the horizontal isotope. X equal to 2 is the vertical isotope. So with that, if you let x equal to 0, then we have y is equal to 1 all over -2 minus 3. So here we get -3/2. So 0 comma -3/2 is our y-intercept. And then if you let y equal to 0, this implies that we have 1 over x minus 2 minus 3 is equal to 0. That is, we have 1 over x minus 2 minus 3 times x minus 2 over x minus 2, and that gives us 1 minus 3x plus 6 over x minus 2 is equal to 0. So that is, yes, 7 minus 3x over x minus 2 equal to 0. Multiplying both sides by x minus 2, we end up with x is equal to 7/3. So 7/3 comma 0 is our x-intercept. And you can write this y-intercept as 0 comma -7/2. Let's see the graph. the vertical isotope is x equal to 2. And the y horizontal isotope is y equal to -3. Thought it was going to be straight. Okay, I'm about to spit in just a minute. Crap. Now, if you know the horizontal and vertical isotope, the rational function takes on a basic graph for y equal to 1 over x. You remember that? You remember that the x and the y-intercepts were the x-axis and the y-axis were the isotopes, so the basic graph. So if that be the case, then you have it. Now the so-called x-intercept will be this point here. So it's a little bit to the right of 2, right? And this guy right here is 2 1/3. So and then the y-intercept is a little bit below -3. That's the -3.5. That's what I want you to see. So this is the point 0, -7/2. Let's look at the next one. Here, x squared plus 3 equal to 0. There is no real value for x. We get imaginary. So for the vertical isotopes, there are none. For the horizontal isotope, you get the line y equal to 1. You look at this fraction, the power up top is 2, the power downstairs is 2. They have the same power. So the horizontal isotope, or the limit for that matter, as x goes to infinity, would be the ratio of the leading coefficients. 1 divided by 1 is 1. This function is always positive. You get x squared divided by x squared plus 3. So y is always positive. What does that mean? Translation, the graph is above the x-axis. We do have an intercept at 0, 0. It's the only intercept that we have. And if you recall, this is the graph that is so famously called the Witch of Agnesia. What was that? Now we need the y-intercept. x-axis, y-axis. This is the line y equal to 1. We have an intercept here at the origin. The graphs tend to try to ride along the asymptote. This is the intercept, but if you look at it, it's the minimum as well, without even having to do the first derivative test. What about this one? We have vertical asymptotes. X is equal to plus or minus 1. For the horizontal isotope, we get the line y equals 0. That's the limit. We have an intercept at 0, 0. Let y equal 0, you end up with 3x equal to 0, so x equal to 0 there. Now what we're going to do is I'm going to partition the number line based on these x values of question, the vertical asymptote and x equal to 0. So this is for y. So here we test a number on the interval from negative infinity to negative 1. Say for example, let's take negative 2. You plug that here for x, we get negative. Plug it here, we get a 4 minus 1, so we get negative divided by positive. That gives us negative. Take a number between negative 1 and 0. Let's say negative 1/2. We get negative there. Downstairs, we will get negative. That'll be 1/4 minus 1. That result would be negative. So negative divided by negative is positive. Take a number from 0 to 1. 1/2 is positive here. Negative downstairs, we get negative. And then over here, we get positive. I think that's all you need to graph this. And here, I'm just relying on algebra for right now. No need to use our calculus as of yet. Straight line. Straight line. I think that's it. I knocked it off. Now for our isotopes. Let's use red for isotopes. That's pretty good. It won't be straight. Isotopes x equal to negative 1, x equal to positive 1, and then y equal to 0 is the x-axis. We have an intercept here, and let's see what happens. So it says from negative infinity to negative 1, the graph is below the y-axis. It's doing that. From negative 1 to 0, positive. From 0 to 1, it's negative. It goes downstairs. And then from 1 to positive infinity, it's plus. It's always above the x-axis and hovers always close to its isotopes. I thought something was supposed to be red, but it didn't come out as red, but that's fine. Obviously, that's the origin, and this is the line x equal to 1. This is the line x equal to negative 1, and then we get the origin. A study of that, notice that you have a point of inflection as well at 0 if you were doing the second derivative. I don't want to with that fraction. but you get everything you need. We got the graph, right? Well, let's consider this one. So I looked at that and I thought we could factor the numerator, but it doesn't come out pretty. So with this one, we need the, you can look at the first derivative to find the so-called relative extrema. I was able to get most of the graph, the basic format, before I even dealt with calculus. Since I've started that, let's go ahead and just find the first derivative. So it's the derivative of the numerator times our denominator minus the numerator times the derivative of our denominator, which is just 1, all over our denominator squared. So here y prime is 2x squared minus 12. Well, this is minus 12x minus 6x. Go ahead and just put that in there. So this is minus 8 minus 6x minus 14x. Then this is plus 24 minus x squared plus 6x minus 12 all over x minus 4 to be squared. So here we get x squared minus 8x plus 12 all over x minus 4 to be squared. And can we factor that numerator? Let's see. X minus 6 times x minus 2 all over x minus 4 to be squared. So if you set y prime equal to 0, this implies that x equal to 6 and x equal to 2. So now we're going to partition the number line based on these values for y prime being set to equal to 0. So 2 and 6. So we test the first derivative. Let's take a number from negative infinity to 2. We'll take 0. You take 0 and plug it in. We get negative times negative is positive. Take a number between 2 and 6. Let's take 3. So we get negative and positive. Gives us negative. A number bigger than 6. Let's say 7. So we get positive there. So this means that we have a relative maximum at 2 and a minimum at 6. Well, it'll be helpful to locate those values for the graph. So y of 2 is 4 minus 12 plus 12, and that's all over 2 minus 4 is negative 2. So that gives us negative 2. So that's the point 2 comma Negative 2 is our max. And then y of 6 is 36 minus 36 plus 12 all over 6 minus 4 gives us 2. So we get 12 divided by 2. We get 6. So the 0.6 comma 6 is our minimum. Now, back in high school, we had a function like this. To graph it, here's what we did. We took our denominator and we divided our denominator into our numerator. So x minus 4 divided into x squared minus 6x plus 12. X goes in x squared. X times x is x squared. X times negative 4 is negative 4x. Draw a line, subtract. That becomes negative. This becomes positive. We combine the terms. So here we got negative 2x. Bring down the 12. X goes into negative 2x. Negative 2 times negative 2 times x is negative 2x. Negative 2 times negative 4. Positive 8. Draw a line, subtract. So this becomes positive. That becomes negative. So we get 12 minus 8 is 4. So this term here is x minus 2 plus 4 all over x minus 4. Now, what does that tell us? I'll tell you what it tells us. Maybe I can write it down here. We have y is equal to x minus 2 plus 4 all over x minus 4. This x minus 2 is it's a slanted asymptote. So the line y equal to x minus 2 is a slanted asymptote. It's not a horizontal, it's not a vertical asymptote, it's slanted. And then from here, our vertical asymptote is x equal to 4. Okay, this guy is in the way. Let's see. Excuse me for 1 second. I need to get my trash out of here. Okay. Don't want to miss the trash, lady. Most important job on the earth, outside of preaching the gospel. Yes. Okay. Well, I'm just joking. There's a lot of other things in between there, but I think keeping a clean place is most important. So anyway, I'm trying to graph. Yeah, I need that first. Straight line. Okay. Now let's go ahead and graph this this slanted asymptote. So it's going to come through on the y-axis at -2. It's not dotted. Something like that. x-axis, the y-axis. Oh, we have a vertical asymptote at x equal to 4. Need that. Okay. So now I know that I have a maximum we have a max at 2 comma negative 2. It's probably helpful to label. This is x equal to 4. So I have a maximum in here. It's negative 2, so it's going to be down there. So this guy is doing this. Then I have a minimum at 6 comma 6, like that. It's the maximum, that's the minimum, right? And then you have a y-intercept if you let x equal to 0. So if x is 0, we get 12 divided by negative 4, so it gives us negative 3. The x-intercept is imaginary, so this is the point 0, negative 3, and it's right up under. This is the line. This point here is negative 2 for y, right? That's the slanted asymptote. The line y equal to x minus 2. Now, here was another question that I had. How do you know that the graph is contained in here and there, or over here and over there? It's going to be symmetric. So if it's here, then it has to be up there. If the graph is over here, it has to be over here. That's a good question. Now, here's what I did to get that. I took the y-axis or the x-axis, and I set y equal to 0, solve for x, of which I didn't get anything that was real. We got imaginary values, so there was no x-intercept. So I took the so-called the vertical asymptote, and I took the critical points on the number line just to see if I plotted some points, would this number give me a point here, or would it give me something over there? And you can do that as well, just for yourself on the side, to make sure that you are actually putting the graph where it needs to be, here in this spot, and over here, over there, and over there. Where could it be? And then here's a question that you can beg: if the graph is here, is it possible to have a minimum there? If the graph is over here, is it possible to have a maximum? It wouldn't work. So the containment would be within the scissors here, right? Well, this guy, we need the derivative. is not rational. It's not something divided by something else, but we can kind of use algebra to be able to detect how the graph is going to look. So we take the derivative of the numerator, the derivative of the first, excuse me, I'm still thinking quotient. So the derivative of the first is 1 times the second plus the first times the derivative of the second. So we get 1/2 times 4 minus x to the negative 1/2 times the derivative of the inside, which is negative 1. We simplify this. So this is the square root of 4 minus x minus sign minus x over 2 times the square root of 4 minus x. We combine these two terms here. So we multiply this term by the numerator and its denominator by 2 times the square root of 4 minus x. And that gives us up top 2 times 4 minus x. It's going to be minus x here all over the common denominator of 2 times the square root of 4 minus x. So y prime is 8 minus 2x minus x all over 2 times the square root of 4 minus x. So this is 8 minus 3x all over 2 times the square root of 4 minus x. If you set y prime equal to 0, this implies that 8 minus 3x divided by this guy is equal to 0, and that ultimately gives you 8 minus 3x is equal to 0. That is, x is equal to 8 over 3. So we partition the number line with this 8 over 3, and we test the sign for y prime. And so you know that we're just saying from negative infinity to 8 over 3, and then 8 over 3 to positive infinity. So let's take, oh, by the way, there's a restriction on this, the domain, because of that radical, right? So here, 4 minus x has to be greater than or equal to 0. That is, x is less than or equal to 4. So if that be the case, then we don't need all of that. So this guy is stopping at 4. Just to be consistent, we'll erase that. All right. So, so this is 2 2/3. So we have an idea. Let's take the number 0, plug it in here to this derivative. So we get positive divided by positive. So this is plus. Let's take a number between 2 2/3 and 4. Let's say 3. So if you do that, this is 8 minus 9 all over something positive. So this is negative, right? So I have a maximum at x equal to 8 over 3. That's what that's telling me. Now what's the y value associated with that? Let's see. So y of 8 over 3 is 8 over 3 times the square root of 4 minus 8 over 3. So this is 8 over 3 times the square root of, this is 12 minus 8, so that's 4/3. So this is 8 times 2 over 3 times the square root of 3. So this is 16 times the square root of 3 over 3 times 3 is 9. So the point is 8/3, comma, 16 times the square root of 3 all over 3. And this is our max. Okay, so that's the maximum. Now it would be helpful to know the sign values for y itself. The sign values for y. But let's see. So if we have y is equal to x times the square root of 4 minus x, if we set it equal to 0, this implies that x is equal to 0 and x is equal to 4. Now I'm going to take just the number line and partition it based on these values. This is for y, not y prime. Right? This just lets me know, am I above the x-axis or below the x-axis? So take a number, this part over here is not even allowed because of our domain, right? The domain is from negative infinity to 4. Take a number less than 0, plug it here, like negative there, and this is always positive, so this is negative. Take a number from 0 to 4, let's plug it in there, and we're going to get positive here, positive there, right? So I think we're ready to graph. Don't forget about the maximum that we have there as well. I think I'm doing this right. Let's see. Yes. So the graph, it touches down on the x-axis at 0, 0, and four, 0, and we have a maximum at 8 over 3, 16 square root of 3 over 3. So I'm just going to graph the dang on thing, and then we'll come back and label these points. I missed the origin. It'd be cool to take the graph and just, okay, do it like that. And it's it was like the first graph. I hate these stupid graphs. Maybe I should come this way because I'm left-handed. It doesn't go that far. Okay, I'm done. You get the picture. You get the point. Okay. Graph is definitely not drawn to scale, but I think you get the idea. I have a maximum there. 8 over 3, 16 square root of 3 over 3. X-intercept at 4, 0. Another one here at 0, 0. If you found that second derivative, of which I do not care for, the concavity would be strictly down. See, the concavity is concaving downward all the time. Right? But you can see this from the graph. No need to even compute the second derivative. So I think you got that one. 2 more problems, and as my friend Troy, was his name Troy? I think his name was Troy up in Indianapolis. Trey, his name was Trey. He would tell me, and we'd be playing and stuff. He said, I'm going to tell you this and I'm going to leave you alone. So look, I'm going to work these 2 more problems right. I'm going to leave you alone. These problems take a little while. So here, notice that if I take y and just factor, can factor out x to the third, this leaves me with 3x plus 4. If I set y equal to 0, looking for the x-intercepts, then here I have x equal to 0 and x equal to negative 4/3. Okay. So 0 comma 0 and negative 4/3 comma 0 x-intercepts. Now, what about y prime? So this is 12x to the third plus 12x squared. Do a little factoring. Factor out 12x squared. Have left x plus 1. If we set that equal to 0, this implies that we have x equal to 0 and x equal to negative 1. These are our critical points. Now, we partition the number line based on the critical points. Negative 1, 0. We test y prime. So to do that, we just pick numbers on these intervals. Let's take negative 2. We plug it here. We get positive. We get negative. That's negative there. A number between negative 1 and 0. Let's say take a negative 1/2. Get positive and positive. Take a number bigger than 0. We get positive. Now, it will be helpful to also investigate the second derivative for concavity and points of inflection. So y double prime is 36x squared plus 24x. Factor out of 12x, we have left. This is 3x plus 2. Set that equal to 0. That implies that x equal to 0 and x is equal to negative 2/3. These are our possible points of inflection. We don't know yet until we test them. Here we're testing y double prime. Take a number less than negative 2/3. Let's plug it here for that x and for that x. Let's say take the number negative 5. This is negative, and that's going to be negative, so we get positive. Let's here take a very small number, right? And between negative 2/3 and 0, it's going to be negative there, but we're going to get positive here, so it's going to be negative. Take a number greater than 0, obviously we get positive. What that tells us is that here this is concavity. Concave up, concaves down, then here concaves up. It's an S. S. Okay, and that means that we have points of inflection here. So we need to find out what is y of negative 2/3. This is the point of inflection. I need this guy. So we plug in that, so we get 3 times negative 2 over, I think there was an easier one. Ah, crap. I need this. Most of it is worked out for us, right? Let's use that. This is y is equal to x to the third times 3x plus 4. I use that. So this is negative 2/3 to the third times 3 times x, which is negative 2/3 plus 4. So this is negative 8 over 27 times, here the 3's cancel. This is negative 2 plus 4. We just get 2. So we get negative 8 over 27. So that's one point. Then the other is at 0, so that's easy. So okay. Thought I closed out my email. Points of inflection. And the section is long as this. Okay. Points of inflection. And x is negative 2 over 3, y is negative 8 over 27, and 0, 0. I think we have everything we need. If not, we'll try to do something. Okay. I need to draw the graph. Good. X-axis, y-axis, and see, what do we need? We got the intercepts, the maximums, and the minimums. That's what I'm looking for. Okay, I didn't label them. Here, the graph is going down, it's going up, so it's going down and up, so we have a minimum at -1. X is -1, so if -1 is supposed to be 3 minus 4, so we get -1, and then we have a nothing at 0, right? Because it's just increasing at 0, right? We have no extrema at x equals 0, because x equals 0 is a point of inflection. You remember? Right? The concavity changed at 0. So we only have one extrema, and that's at -1, -1. So -1, -1. Make it bigger. So this was our minimum. And let's see how this graph is doing. Anything less than -2/3 is concaving upward. Right? So anything less than -2/3 is concaving upward. Then it gets to 2/3, and then it shifts there, and then it starts to concave downward. Then we have a point of inflection at 0. So it does a little wiggly there. Then it concaves upward from 0. So it's going to do this. And it looks like the concavity changes. Then it does that. Then it does that. So let's see if we got it. So at this point here, we have the minimum. So the minimum is at -1, -1. Then we have a point of inflection here. If this negative x equals -2/3, so it's concaving upward. Then here it starts to concave downward, and then it goes back up again. So it's concaving downward, upward. It concaves upward, excuse me, down, and then it concaves up. Yep. Point of inflection there, point of inflection there. Right. And then we have the intercept there. Then we get the intercepts. That's the -4/3. -4/3, 0. This point there is that point of inflection. The -2/3. Comma, -8/27. Then we had another point of inflection at the origin. Okay. That graph there is kind of tricky. Got to be careful. So as Lee Van Cleef told his merry men in the Good, the Bad, the Ugly, he's told his guys, there are two of them, talking about Clint Eastwood and Levi Wallach. He said, there's two of them. Then he said, watch out. Look, I'm telling you, with these kind of functions, watch out. Alrighty. So, last one. And after this, we take a big break, right? We go somewhere and do nothing for like 2 hours. Alrighty. So we take y. I'm going to just factor out x. We get x to the 4th minus 5. If we set that equal to 0, this implies that x equal to 0. And then x to the 4th minus 5 equal to 0. X to the 4th is equal to 5. That is, x is equal to plus or minus the 4th root of 5. So here, these would be our x-intercepts. So now, what about y prime? So y prime is 5x to the 4th minus 5. Factor out a 5, and then we can factor. This is x squared minus 1 times x squared plus 1 equal to 0. This implies, my implications doesn't look so good. This implies that x is equal to plus or minus 1. So let's take the number line and partition it based on the critical points here. This is for y prime. So 0 is in the middle. So take a 0, plug it there, we get negative. Take a number less than -1, plug it here. Doesn't matter here, this is always positive. So we get positive, and you get positive over there. So that tells us, yes, that we have a maximum at -1. It goes up, increasing, then negative, decreasing. So a max at, if x is -1, so this is -1 minus 5, so it gives us a -6. and then we have a minimum at x equal to 1. So this is 1 minus 5. We get negative 4. Oh, x is negative 1. I'm sorry. This is negative 1 plus 5. Negative 5 times the negative 1. So this is negative 1 plus 5. We get positive 4. So negative 1 is negative. So positive 4. And then at 1, this is 1 minus 5, negative 4. Okay. Kind of losing it. Okay. Oh, my neck. Alrighty. Got to investigate concavity and inflection as possible. No? Let's see. That just becomes 20x to the third. You set that second derivative equal to 0. This implies that x equal to 0. So let's partition the number line at 0 and investigate y double prime. So take a number less than 0, plug it there, we get negative. A number bigger than 0, plug it in here, we get positive. So we have a point of inflection at 0, and that'll be, even I can get that, 0, 0. Whew, it's an easy one. Good, right? So this is concavity, concaves downward, concaves upward. So here we have a point of inflection at 0, 0. So I think we have everything we need to graph this sucker. I'm going to get you sucker, a classic movie that I do recommend. Straight line, straight line. All right, point of inflection at 0, 0. We have a maximum at negative 1, 4. Negative 1, 4. Let's say it's here. And then we have a minimum at 1, negative 4. There. So here's what it's doing. It's doing that. It's doing that. It's doing that. Let's see if the concavity is true. So from negative infinity to 0, it concaves downward. Good. And then from 0 to positive infinity, it concaves upward. That's what that says. So this was our minimum at 1, negative 4. And this was our maximum at negative 1, positive 4. And then you can see the point of inflection. Oh, what about these guys here? This guy right here was, this is the 4th root of 5, 0, the x-intercepts. The negative 4th root of 5. Comma 0. And then obviously we have there another x-intercept, right? think that'll do it. Hopefully that information is sound proof. Thank you. An hour.